Water, water everywhere. But not a drop to drink. This age-old saying is becoming more and more relevant with each passing day. As the weather changes, the number of industries increase, and of course, the sheer numbers when it comes to population growth has led to immense pressure on water resources the world over. It's time we take a closer look to understand more.
You see, water is a very, very essential commodity, and it is in virtually life, and it is actually life, and all over the world there is right now one of the big stories is how the world is going to handle the water shortages in future. So I have instructed this Ncess to make a list of or a good quality data bank of all the good, positive, environmentally useful deeds, and of course positive deeds which will help in not only rainwater harvesting but also water conservation in any form, so that everybody is contributing to this noble cause.
In the natural water cycle process, the surface water bodies get water from rains, which in turn contribute part of it to the groundwater. Surface water and groundwater are mutually dependent. Rainwater harvesting has become critical to restore the natural balance of groundwater and surface water, and thereby helps improve the water availability, both in terms of quantity and quality. The benefits of rainwater harvesting. The enhanced recharge to groundwater indirectly benefits the ecosystem in many ways. Maintains the flow of rivers in summer. Avoids pollution of water bodies. Reduce drinking water scarcity and improve the overall environment with its nurturing properties. River basins could be rejuvenated and aquifers can be maintained to ensure water supply through rainwater harvesting. Conservation of rainwater and recharge of shallow aquifers through artificial recharge techniques can solve at least a part of the problem emanating from the scarcity of water or drying of sources. The ultimate source of water to an underground aquifer is always rainfall or precipitation only. Watershed is a natural geographical unit where all the water falling within it as rain goes out as surface as well as groundwater flow, only through a single exit. By regulating inflow and outflow from the watershed, an underground reservoir can be made to function beneficially and indefinitely, similar to surface reservoirs. India has diverse landforms, rainfall patterns, climate conditions, and therefore water availability. Rainwater harvesting has formed part of Indian traditions, and over centuries, the people have innovated techniques to harvest rainwater to every last drop. People used to consider water resources as part of nature, which is essential for the survival of mankind. The benefits of artificial recharge to aquifers compared to dams, etc. include free subsurface storage space and inundation is avoided. Minimal evaporation losses. Quality improvement by infiltration through the permeable media. No adverse social impacts such as displacement of population, loss of scarce agricultural land, etc. Temperature variations are minimum. And it is environment friendly, that is, it controls soil erosion and flood and provides sufficient soil moisture even during summer months. On the surface, Kerala is a lush green state with abundant water resources. With 44 rivers, and over 3,000 millimeters of average annual rainfall. One would think that water problems are distant. However, being a developed state along with its high density of population has led to a strain on the resources. In order to combat the ever-increasing demand for water, larger water projects, deeper tube wells, and wider network of distribution system are provided. This has led to falling water tables and unprecedented drying up of sources. Current methods of rainwater harvesting are falling short of the increased requirements. However, these are some of the methods followed. The normal method of calculation of annual yield from roof harvesting is as per the formula Q equals A into R into C into 1000, where Q is the yield of water in liters, A is the area of roof in square meters, R is the annual average rainfall in meters, and C is the runoff coefficient. The runoff coefficient for roof with GI sheet is 0.9, asbestos sheet 0.8, tiles 0.75 and concrete 0.7. Reports say Kerala has more than 15,000 ferro cement tanks already in schools, hospitals, government offices, etc. In addition, plastic, concrete, brick masonry, silpaulin sheet are also used for constructing storage tanks. In many areas, abandoned quarries were converted as rainwater storage tanks. The National Centre for Earth Science Studies, Ncess, is India's leading institute when it comes to the earth sciences.
Ncess is a premier national research institute that carries out both basic and applied research in all aspects of earth sciences. Here we have a strong dedicated team of scientists who are working on all aspects of water, whether it is groundwater, resources, contamination, pollution and so on. One of the important topics that Ncess has been addressing over the last few years is the very important aspect of rainwater harvesting. As you know, the country's needs for water is extremely pressing at the moment and it's going to be more difficult in future. So what at Ncess we do is we try to combine our expertise in both geology, hydrogeology and also geophysics, which enables us to map the subsurface structure, the geological structure beneath the surface, and using this information and this expertise, we try to find more innovative methods of carrying out rainwater harvesting in different geological terrains.
Dr. P.K. Thampi, the former head Geosciences Division and professional water consultant, has received awards from CGWB in recognition of his contributions.
Kerala receives rainfall about 3 times the national average. In spite of this high rainfall, this region experiences severe water shortage during the summer months.
Sri John Mathai, retired scientist and senior consultant, Ncess, and member State Environmental Impact Authority.
We have been carrying out experiments for water conservation, mainly rainwater harvesting in different parts of the state and even elsewhere. Our experiments show that not only the rain, but also the terrain factors have to be taken into consideration. By terrain factors, I mean the real shape of the land and the slope, the material that make it, and even the substrate, the geology of the area. Basically, to see that the water is conserved in that particular place.
Dr. D.S. Suresh Babu, scientist, Ncess, who is currently spearheading such activities in the centre.
This rainwater harvesting becomes very important. Traditionally, we know people used to harvest water and store in pots, ferrocement tanks, then silpaulin tanks and things like that. On an individual basis, this is fine. And for a community basis or a watershed basis, we need a larger intervention. And the subsurface dike is one proven method to do the rainwater harvesting.
Having identified the problem in Kerala, the government deployed Ncess on a reconnaissance mission to understand the problem and identify solutions to mitigate the same. In Kerala, the steep sloping terrain conducts all rainwater swiftly to the Arabian Sea, giving little chance for percolation and augmentation of groundwater resources. Water table is less than 5 meters below ground level immediately after the monsoon, and at the same time, the state faces acute water shortage in summer. This is mainly due to the draining of water from the phreatic aquifers to surface water bodies in coastal zone or to sea due to the topographical constraints. Hence, unless the groundwater flow is checked on a micro-watershed basis, it is not possible to make available even part of the infiltrated groundwater during the non-monsoon months. Significant changes can be made with the support of subsurface dikes only as it regulates groundwater flow towards downstream. It is scientifically known that vast underground reservoirs are available in the form of aquifers below the surface of the earth, which can store water for retrieval at times of need. This will not only improve the groundwater availability both in terms of quantity and quality, but also make the rivers and surface water bodies in the region perennial. By establishing a subsurface dam at the exit point of the watershed, a subsurface reservoir could be established which can store the entire water recharged into the groundwater within the watershed area. This will assure the sustainability of wells and other extraction structures within the watershed. If we can plan at least one micro-watershed in every panchayat, it is sufficient to maintain drinking water supply to the entire panchayat during the dry season. The artificial recharge projects using subsurface dikes are site-specific, and even the replication of the techniques to similar areas should be based on the local geological, geomorphological, and hydrological setup. The first step in planning the project is to demarcate the area of recharge. The project can be implemented systematically in case a hydrologic unit like watershed is taken for implementation. Selection of a site in the watershed shall be in areas where water table fluctuates regularly between rainy period and lean months, or where threat of salinity ingress exists. 4 types of source water may be available for artificial recharge, which are in situ precipitation on the watershed, surface or canal supplies from large reservoirs located within the basin, surface supplies through trans-basin water transfer, and treated municipal and industrial wastewaters. A micro-watershed with a pond at the exit was selected for detailed analysis, and a subsurface dike was constructed under the supervision of Ncess. Construction of the 160-meter-long subsurface was completed at a fast pace before the monsoons, and the well-planned experiment became another success story of Ncess.
Ncess has already established its expertise in the state of Kerala, where it has been working for a very long time, and it has helped the local people, the farmers, etc., to optimally utilize the runoff to get the best possible means for rainwater harvesting and to preserve water for future.
The project has been very helpful for the villagers of Vadakarapati in Palakkad district of Kerala. The subsurface dike means that today the villagers don't have to wait for water container trucks. There's enough water for all their needs. Another merit of the project is that it helped lower the mineral content in the shallow groundwater, enhancing its potability. By rendering the ponds perennial through appropriate intervention, the water stress of this region has been alleviated considerably. With this success behind it, Ncess is looking at the different regions of India. In areas where climatic conditions are not favorable for creating surface storage, artificial recharge techniques have to be adopted for diverting most of the surface storage to the aquifer system within the shortest possible time. Ncess is proposing water management and rainwater harvesting as the future path to the availability of fresh water. This is our only way to keep the water crisis at bay. After all, water is everything we need for life itself.